Today we're going to do some talking about saw blades. Okay, so there's always a backstory, right? So here's the backstory. I struggle with resawing certain woods on my vertical bandsaw. Now it has a 16-inch capability, and I even own a very nice Resaw King carbide tooth 1-inch thick blade, but I still sometimes have trouble getting perfect cuts. And so some of it is alignment issues, but it's endless. You know, it's like I have the saw set up perfectly and I'll get a really good cut, and a couple weeks later, month later, whatever, I'll go back and I'll do a cut and it's not right. And so it requires ongoing maintenance, which I don't always have time to do the level of detail as I would need to. So I get frustrated, especially when I have a nice piece of figured wood that I want to make a matched, book matched top for. And there's two problems that happens. Number one, theoretically, if the board is 9/16 inch and I take it to the bandsaw to resaw it, I should be able to get 2/4 inch totally book matched halves there. The key with getting a good book match is taking off as little material as you possibly can. The more material you take off and then you butterfly those two pieces open, the less the grain pattern will line up. If you take off very little wood, you're going to have a more perfect grain pattern match in that book match top. So that's what I really struggle with. Plus, I don't like wasting wood. If the cut's not perfect, I have to then plane it down and then sand it flat, and I end up losing valuable wood, especially if we're talking about exotic woods and things like that. That is my struggle. That is my frustration. I know what the perfect answer is for this, and it's a tool that some of the bigger shops use, and it's a very expensive tool, and I'm not going to go into that. But how do we do it better with the tools we do have? And for me, it's a table saw joiner, planer, bandsaw. Okay, those are the tools that right now I have access to make this work. And how can I do it better? Well, sometimes I'll resaw boards that aren't that wide strictly on the table saw because I know it's going to be true and flat, and I don't have to leave myself as much of a buffer. So one of the things I've done in the past is I've used the table saw as a resaw starter. Okay, so now I've got this body blank that's 13, 14 inches wide. But in order that I get a better cut on the bandsaw and I don't have the blade beginning to wander and kind of follow certain grains, especially in the harder woods, I'll do starter cuts on the table saw. And that is just setting the depth of the blade, and I generally take 1.5 inches or so each pass, and I'll make a cut, I'll flip it over, I'll make another cut, I'll raise the blade, I'll make another cut, and I'll go through as much of that material as I possibly can with the table saw before taking it to the bandsaw to be resawed, and I get much better results. The problem still falls in the area of kerf. The kerf on my standard table saw blade, which is a Forest Woodworker 2, is what I've been using on my saw. And it's a 12-inch blade. I do have a Bailey 12-inch 5 horsepower table saw, and I tell you what, it's the best thing I've ever added to the shop. It really, having that horsepower and something that weighs, seriously, I don't know, like 700-800 pounds, really makes my cutting a whole lot easier. But anyway, sidebar tangent. This blade here is a little tiny bit over 1/8 of an inch. 0.1265 is what I measure with the calipers for the carbide tips. So it's about 1/8 of an inch that I'm taking off every single time. The bandsaw blade, the Resaw King blade, is 0.050, 50 thousandths, as opposed to 126 thousandths. Okay, that is less than a half. It's 2.5 times thinner. So what I'm doing is I'm losing extra valuable material, and I'm also messing up the book match, because that 1/8 inch is going to make a difference of how that grain lines up. It's going to make a significant more difference than if I were able to just shave off 50 thousandths as I was cutting this, and if it was perfect enough that I didn't have to do a whole lot of sanding flat after that. So I began my search for a better thin kerf blade, and most of them were falling in the area of 90 thousandths for a thin kerf blade. And I was thinking 90 thousandths, well, okay, that's better, but that's still almost twice as thick as my bandsaw blade is. So I'm still losing material that I don't want to lose. I'm losing book match that I don't want to lose. There's an old saying that you can't always get what you want, but if you try, sometimes you'll find you get what you need. I forget who said that. Some poet or something like that. Anyway, so I've been searching for a solution, and sure enough, I found some information on the internet about something that's called a micro-kerf blade. Micro-kerf. What is a micro-kerf blade? Well, that took me to a company called Total Saw Solutions out of Wisconsin. Or is it Wisconsin? Anyway, this is pretty cool stuff. So they make all different sizes and all different kerfs. In fact, I'm talking to them right now about making a fret slot saw blade specifically to my specifications, 25 thousandths thick for my burn saw. Okay, and I think that is pretty sweet, because that 25 thousandths will be a carbide tooth blade, which should last me a lifetime, basically. Anyway, in looking up these solutions, they have normal table saw blades as thin as right just over 60 thousandths, 62 thousandths, I think is what it says. And that got me thinking, that's pretty amazing. Now, I have a 12-inch table saw, so I needed to look at 12-inch blades, and they offered them. And their 12-inch blades had a kerf listed as 70 thousandths. Okay, so still not too bad. It's 20 thousandths more than my Resawing bandsaw blade. That's not bad at all. That's only 10 thousandths on either side of that blade that I will need to run through the drum sander in order to get it perfectly flat. So I can live with that. Now, I got this blade just in yesterday. I haven't even used it yet. I'm going to walk you through this process, because based upon all the information I'm reading about this saw blade, I think it's going to be pretty impressive, and I want you to catch my initial impressions of the saw blade. Originally, I was thinking just as a resaw starter. Now I'm thinking of strips, okay, laminate strips for my necks. Could be easily done with that and lose a whole lot less material. The book match tops we're talking about are about 7 inches wide is typically what I take my billets to. Well, this saw blade has a cutting capacity of 4 1/4 inches. So I can go all the way through the 7-inch piece of wood, working one side and the other side. Now, it doesn't mean I have to. It's easier when you're doing the table saw resaw starter process if maybe you leave enough wood in the center so it doesn't come in two. And then you could just take it to the bandsaw and it'll rip it. Maybe I'll leave 1 inch in the center or something like that. But I could go all the way through this thing, half on either side if I really wanted to. And I'm thinking to myself, that's pretty impressive. And with a table saw, the cut should be so flat that I don't have to allow an extra 60 thousandths in order to flatten and sand. I can maybe only allow 20 thousandths total. You know, maybe 10 thousandths per side is enough to get it totally flat. So here's what it got me thinking. If I'm cutting strips for my laminated neck, and I have an 8-inch board, and the strips that I'm trying to yield in final dimension after sanding and everything are 1/4 inch, and I've got to leave a 60 thousandths allowance because I'm not confident in the sawing capability and how accurate it is, and then I'm losing another 1/8 of an inch because of the standard saw blade that I'm using. That is 0.190 inches of waste that I'm creating. So in that 8-inch wide board that I'm creating these strips from, I would end up yielding about 25 strips. Now with this blade, which is about a 1/16 of an inch, and if it's such a fine cut that I only have to leave, let's say, 20 thousandths of allowance there, and the blade kerf itself is less than 0.070. I actually measured it already. It was 0.067, 67 thousandths. In that same 8-inch wide board, I can now yield 37 strips. That is a 50% increase in my yield. Plus, I'm not creating as much sawdust. Therefore, my dust collection system isn't filling up as quick, or there's not as much going into the air, whatever, but there's certainly benefit by not creating as much sawdust. And if what I show you here today proves to be as good as I'm thinking it might be, then maybe some of the exotic woods that I'm buying to create my own fretboard blanks, maybe I take them right to the table saw and I cut them and I only lose 20 thousandths more than doing it on the bandsaw, but I'm guaranteeing that it's going to be straight and flat. All right, so this blade comes very well packaged with a lot of information in there. Some information was like, oh, that's pretty good to know type stuff. But here is the blade. So what they use is they use these other stiffeners down here, and I guess I would call them stiffeners. That's what I'm used to them being called. But what they actually are doing is becoming a heat sink. They're pulling heat away from the rest of the blade down into the hub area where it's a little thicker and more rigid down there. And that's allowing the blade to work harder without overheating, because overheating a blade is not good, okay? It can cause warping and other issues. So that's pretty interesting design in itself right there. I'm going to give you a nice close-up of this blade. It's just beautiful, the machining. I had the tube off, the teeth are sharp, without a doubt. There's the specs. There's the company and their phone number. So if you can't tell, I'm pretty excited about this. So without any further ado, let me get this on the saw and let's start making some cuts and see what we can do with it. The installation is pretty straightforward. They gave a nice little pointer on their instructional information to keep this rubber tube wrapped on there, and that'll keep you from scratching your hands or forearms when you're down in here working. I do have the machine disconnected from power, so that's also an important thing to do. Because we're not doing through cuts, and because the blade is so thin, we will not be using the revving knife. Because of the way different saws are designed, you may not get full capability. Like this blade has a capability for a depth of cut of 4.25, 4¼ inches, but I'm getting right at 4 inches, and that's part due to my arbor design on this particular saw. But 4-inch depth of cut out of this blade, 1/16 inch wide. That's pretty impressive. Let's start off just by working with some hard rock maple and just start cutting some strips. I'll pull this down so just a little bit, 1/4 inch or so of that blade is exposed, and let's make a cut or two. I just made a cut that is 68 thousandths, just over a 1/16 inch. In fact, it's the exact same dimension as the blade itself right there. But that is a perfect strip. The one that was previously cut with my other saw, you can see saw marks right on the edge. This one, I can barely even see where the saw cut. It is such a smooth cut. All right, let's try something more interesting. Let's try a slice of 2-inch thick Purple Heart. (1/16) 2-inch thick Purple Heart. Pretty smooth cut. All right. Now let's try resawing and book matching some of this flamed maple that we've got here. Okay, I did joint this side down, and I ran basically one edge through the jointer, the other edge through the previous table saw, blade. Now I'm going to set this up and start maybe about 1 inch high, and I want to leave myself a final dimension of 1/4, so I'm going to go an extra 32nd. So I'm going to leave myself basically an extra 30 thousandths. And I'm going to basically cut on both sides all the way around, and I'm probably going to stop when I have 1 inch left. And we'll see. Maybe I'll go for it and I'll just do the whole thing. But let's see how this goes. I got about 1 inch left right there that I can do on the bandsaw. But while I'm here, let's get another one out. So since I cut these nice little maple 16th inch wide strips, which are exactly the same thickness of this blade, I'm just going to put those to stop the wood from compressing. Just put those strips in the center, and now I can set my new distance and still have this reference surface as my reference surface. And now I can cut these, and I should have perfectly sized boards ready for just a little bit of sanding on the drum sander after we cut them with the bandsaw. So it should be a good solution. Honestly, that was so stable and so easy cutting. I bet you I could just go all the way through with no issues. But just for demonstration purposes, let's go over to the bandsaw and finish the resawing process over there. All right, we got the Resaw King on there, and I've got it set up to go right down the center of the second slot that I cut. Since I still have the spacers in the first one, I figure that makes more sense. Take care of that one and then move into the next one. So again, we're only cutting about 1 inch less on that one, so it should be relatively easy for this big saw blade. In fact, I almost half tempted not putting the Resaw King back on and just using a 1/4 inch blade that was on there just to cut that one little 1 inch strip. I think that probably would have been fine. That is almost dead flush. There's my book match right there. This is the cutoff. This wasn't part of the book match. The thinnest corner was 5.8 millimeters. And now the overall height after running it through the drum sander is 5.4 millimeters. So I lost 0.4 millimeters, or 16 thousandths of an inch is all I lost on this board. 16 thousandths. I've got the book match pieces over on the glue rack, gluing them together prior to sanding them flat, and let's see what that comes up with. Makes me think, what else can I do? Let me show you the back of this guitar. This is something that I often do, and basically I use a cutoff of the back of the guitar to create the cover plate for the guitar. Now, it's more important when I'm doing more of a natural wood finish, because the grain will totally match up if I can cut it. Now, I can't cut it out of that back piece, but if I'm putting a top, a drop top or a highly figured top on there, I basically get my wood blanks at 1 7/8. That leaves me 3/8 of an inch, which means I can go cut that and have as much as a 1/4 inch, if not more, maybe 5/16 of an inch off of the back of that slab to cut my covers out. And I don't need them that thick, but you see, when I'm cutting them close to the final back, and then the side that it's cut from will become the side that's closest to that, because I will sand down from this side to meet the thickness that I want. These will be almost perfectly book match every time. So this is another thing that is very useful for the resawing, so I can resaw the entire back off this thing and use it for cover plates. Let me show you. So in this particular case, we've got our body that I showed in one of my template videos recently. And the body has got a 1/4 inch padauk top that's going to be going on it. And this is 1 7/8 still. I don't need 1 7/8. In fact, I need significantly less, 3/8 of an inch less, once the padauk top is on there. So basically, I'm going to do the exact same process, running it through the table saw to get most of this, as much as possible, cut out, and then I'm going to take it to the bandsaw and resaw the rest that I can't get with the table saw. Now I'm going to set this saw, a 1/16 inch micro-kerf blade, up to 1.5 inches, plus the 1/4 inch padauk top should be perfect. Let's take about 1.5 inches per pass. So this is the top, which will be buried by the padauk. So we want to cut off this side and save that. You notice my alignment pin holes are still part of this block of wood, and that's going to help me for something very key to making these cover plates. Having 4 inches of that blade sticking out of the saw is a little bit intimidating, but this thing cut extremely well. There was a little bit of hang up the edge of my table. The insert is not quite level enough, and so I was kind of hitting that bump, so I'll have to adjust that later. But the saw was cutting so butter smooth that there was no probably burning whatsoever in there. Once we peel it up, we'll see, but that's awesome. I took it to a full 4 inches, so that's 8 inches out of the 12 3/4. So that only leaves me at the widest point about a little less than 5 inches that I'm going to have to clear. This is pretty cool though. I was watching the blade cut down my slot and it was staying dead center in that slot. It's following the path of least resistance, and that's pretty sweet right there. That won't take a whole lot to clean up both sides of these, and that keeps my grain pattern as close as possible to each other so my cover plates will match almost identical in the grain pattern. I took a 4/4 piece of lumber that started off at 7/8 of an inch, and I made 3 slightly under 1/4 inch pieces, 2 of which were designed to be book matched. I'll give you a close-up of the book match side. really not bad at all. Lines are converging. The flames, if you can see them, are pretty opposing each other, which is what we want. And again, that only comes by removing as little material as possible in that book match. And I'm liking the results. Then we've got an extra piece here. Now I should have gone a little thinner on the last piece because my second cut here was slightly thinner than I wanted it to be, so therefore the whole thing had to come down to be slightly thinner. It's about 0.21, more than enough for a drop top for sure, but that's where it's at right now. And this guy is almost a full 1/4 inch left over, and again my idea is to use this for head plates, matching head plates with the body top, and in that case I could have gone all the way down to 1/8 of an inch on this guy and left a little bit more buffer on these, but still I'm very, very happy with the book match. Alright, so here's the other one. Here's the padauk top that I was telling you about. Just set that aside. Here's the walnut body with the routes ready to go, and then we've got the piece attached to it, which came off of it. And I've got better than a 1/4 inch left over here. In fact, I calculated that after the saw kerf itself, in sanding it totally flat, I only lost another 25 thousandths of an inch because it was so almost perfect that it didn't take much sanding to get both this side and this side perfectly flat. Now these are the match sides with each other. So the key thing is when I do any stock removal to get this to the thickness that I want for the final electronics cavity covers on the back, I have to make sure I remove the stock from this. That's the non-match side, and keep these two as close to final dimension as possible. I'm going to put these back together for a second, and I just want to show you how good that grain matching is. Okay, I'm just holding these together with 2 fingers, because that's all I can really do here. And look at the knot, look at the grain. I mean, it's almost dead matching all the way around. That's how little material was removed. So if you want to know if I'm happy, yeah, I'm pretty happy. This micro-kerf saw blade is truly amazing. It cuts so well, it's so precision, it's so thin for these book matches, for anything like that. It's just going to make life so much easier and the end result so much better. The fact of the matter is, that company, Total Saw Solutions, is just a small company. But they got really high expertise and they got high-end equipment to do all of this stuff. They do specialty projects for the federal government and for NASA and things like that. And now I'm talking to them about making a special carbide blade for my fret slotting saw. That's how impressed I am with the quality of what they produce. Now the downside, it's a little bit on the expensive side. The 10-inch blades are around $200 and my 12-inch blade was about $250. So that's a little bit expensive, but I tell you what, if it makes the quality of the end result that much better, to me it's worth that investment, because it's not something I'm going to have to do all the time. That blade's probably going to last a long time. It can be resharpened and things like that. So well worth the investment to me. And that's what I really wanted to show you today. It was my first look at this saw blade, and I am every bit as impressed as I thought I would be. So check it out. And remember, no matter what you do, start with excellence.